Welcome to this demonstration called Train and Explain using Snowpark ML. This will be a demonstration of the Snowpark ML Python library. Well, first, we're going to quickly look at some data and what features we have available to train this model, create a preprocessing pipeline, then train a model using the Snowpark ML library, and then register it. Then we can take this registered model and load it up and look at some behaviors that it has. So let's dive into it. First, we're going to quick look at some data pre-processing steps that might be necessary for our data. So we use our Snowpark table here to just inspect some rows of our table. We can see we got some very nice numerical rows, but we do have one categorical column, which for XGBoost, that's going to be needed to turn into a ordinal column. So we can kind of check quickly. We can kind of look through the distributions of these different models, see if they need to be cleaned up, renormalized, or things like that. With XGBoost, it's not as big a deal, but this interface gives us a quick way to look at that. And we can see that there's one categorical column, so we're going to have to deal with that. So we dive into our Snowpark ML library, and we see that we do have an ordinal encoder, which is a wrapper around the scikit-learn ordinal encoder. So we can use that to deal with our categorical variables. So we tell it that which columns have our categorical variables and what our new categorical columns are going to be called. Calling fit on our data frame shows us that it turns our categorical into a numerical column right here. So now we know what data processing needs to happen. Let's dive into the actual training. So our model training script will first connect to our Snowpark session, and we then define all of our columns that we need for our modeling. Then we can see we're going to create this ordinal encoder as our single preprocessing step that's needed for this pipeline. And then we can grab from any of the common open source libraries, scikit-learn or XGBoost, to create our model. So here we're using the XGBoost regressor, and you can set any of the parameters, hyperparameters that you want here for our XGBoost model. And so we define which columns we want. Once again, here we're using the output of the ordinal encoder using that column name, and that will be our model step. So we've stitched these together into a pipeline. It's very similar to the scikit-learn pipeline where you have steps defined by different transformers. So then we can use our Snowpark table and you define our train test split using Snowpark and pass that training data set into our pipeline to train our model. None of this data even hits my machine, even though I'm running it locally, because this will be using the Snowpark, using our Snowflake compute, because it's Snowpark. After the model is trained, we get a prediction. We can get our predictions for the test set and calculate some metrics. Then through here, we hook up to the model registry and we can log our artifacts and things like that. So I'm just going to kick off this script here, or we can train model, and we're going to just call this version 6 and kick that off. So now that our model training is completed, we can hop over to our Streamlit application and look at some model explanations. So the new model, if we refresh this page, we can then get a new, we can see our new version of the model, version 6 will be available. And we can pull in that model version, and Streamlit will load in that model from the model registry using those artifacts. And then we can do some summary plots on our data. We can do a what if analysis on our data. We can choose different numbers here for our input features and see how that impacts the predictions and how it impacts all of the different contributions for the different features. We could hop over to our partial dependence plot and see how each feature is contributing to our model performance. And so that's our demo. I hope you enjoyed.